and Ollie, and they will be filling in the gaps in documentation and the official guidelines in order to help you deploy bulletproof microservices with Spring and Kubernetes. Take it away.
Spring one session on Bulletproof microservices with Spring and Kubernetes. My name is Ollie Hughes.
My name is Bella Bai. I'm a software engineer on the Spring Cloud Commercials team. My actual name is pronounced as Bai Yuxing, as you can see on the screen here. And it has a tone, but you can just call me Bella. I live in Boston, Massachusetts with 2 rescued kitties, Chocobo and Paprika. During this special time, I developed some new stay-at-home hobbies, baking and sketching, and I like to make them animal-themed. Back to you, Ollie.
Hi, so my name is Ollie Hughes. I live in Southampton in the United Kingdom. I joined VMware through the Pivotal acquisition along with Bella, and we're building a commercial distribution of Spring Cloud for enterprise customers. So I'm a really big fan of Kubernetes, and I feel very lucky that I've been able to gain a fairly deep understanding of the platform as part of my job. So I love, as you can see from these pictures I'm about to click through, that I love spending my spare time either sort of by the ocean or in the mountains. And I also have a little dog called Snowy, who's 1 year old. Unfortunately, the cat in the picture isn't mine. We actually just found him and met him on a walk. So actually, animals are going to be a little bit of a theme in this talk, because we're going to be talking about topics like Kubernetes and security. It's going to be a little bit dry, so hopefully we can present these concepts in a slightly more light and entertaining way. So we chose the title Bulletproof Microservice for this talk, because we spent quite a lot of time lately figuring out what is the best way to run Spring apps on Kubernetes, and especially within a secure environment. So we quickly found deploying and securing an app isn't that simple when you're running on K8s, especially if you're coming from something like a Cloud Foundry environment where there's really quite a lot of security concerns that are handled for you by the platform. The product Bella and I work on is widely deployed to a number of major banks and insurers, so it's vital for them to make sure that the product is very secure. Kubernetes does provide you with all the building blocks you need to build a secure system, but really it's up to the developer to do a lot of the assembly of these components. What we wanted to share with you is some of the examples that we've found along the way and how you can build apps that are sort of ready for production on Kubernetes. So another reason that we wanted to give this talk is because we kind of noticed that the kind of responsibilities of the developer are increasing over time, and you often hear terms like full stack and DevOps. And in reality, what this can often mean is that there's more tools to learn for developers, and there's more expectations beyond just writing code and deploying it. But thankfully, Kubernetes can definitely make deploying applications a lot easier and certainly more consistent once you have the prerequisite knowledge and you understand the right tools for the job. So hopefully we can show you some demos and live coding that will show how K8s deployment can be a lot simpler and also suitable for production environments. So we kind of asked ourselves the question, as developers, what do we want to do? What do we want out of our sort of platforms? And really, I think the main thing that we want is to spend most of our time focused on dealing with helping customers solve their problems. And when we have to write a lot of code that doesn't directly fulfill these needs, such as sort of writing code for security, it can kind of feel unproductive and sort of less direct value. So what we want to do is show how we can use Kubernetes to delegate certain parts of security management. In particular, we want to explore how we can use HTTP authentication and certificate management with Kubernetes instead of getting our apps to do this. So we definitely think this is a really good thing. By doing this, by using Kubernetes to do these kinds of concerns, because it means that app developers can be more focused on building business logic and spend less time on security and infrastructure concerns. So just quickly want to have a very sort of high level look at the architecture of the app we're going to deploy as part of our demonstrations. So what we have is a Kubernetes deployment, and this is responsible for managing the lifecycle of our applications. And these apps are packaged as containers, and in Kubernetes terms, we call it a pod that manages one or more containers. And then we have something called services, and services are what are used to actually expose our apps over the network so they can be accessed from outside of the cluster. Okay, so on to our first demo. In this demo, we're going to deploy an application called Animal Rescue. And this is made up of a Spring Boot API, a web front end, and a small Node.js API. Really, we just wanted to show something slightly bigger than the usual Hello World style app, so we can kind of see the collaboration between different services. And we're also going to introduce a couple of tools that will help you along the way with deploying to Kubernetes. So just have a quick drink. So you can see just a typical sort of layout of the project, typical sort of Spring Boot app. We have a folder called backend, and this is what contains our sort of API and web resources, the Spring Boot app. This app actually provides a service where users can see animals that are available for adoption and register their interest. So as we said before, this is a bit more fun than Hello World. You can see there's a build.gradle file, and it's just the normal kind of set of dependencies you might see with using Spring Web Flux. So it's a reactive app, Spring Data, and actuator and security. What you might notice is there's no actual sort of special dependencies for Kubernetes, and this is really one of the kind of core mantras of Kubernetes. Kind of, you should be able to run any app. You shouldn't need to do anything special, or need any kind of special connector or anything like that. Now I'll close the backend, and we've also got an external API. Now this is just a really simple Node.js application. And so we also wanted to show that how you can use in Kubernetes, you can quite easily use common patterns for deploying different types of apps. So nothing that we're doing is particularly tied to Spring or Node, so it should work across multiple types of apps. And the purpose of this actual API really is just to sort of interact with the animal rescue microservice and sort of provide some extra data. Okay, so let's move on to see how we actually deploy the app itself. So we're using a tool called Scaffold to do our deployment. Now, this was developed at Google, and what it does really, it just manages the local workflow that you need to deploy an app. So without Scaffold, what you'd have to do a proper deployment is have to actually run a few different commands in sequence. So number one, you'd have to build your app, and in this case, using Gradle or the Node npm packaging tool. You'd have to build the image using something like Docker and create a tag for it. And you'd have to push that image to a registry. Then you'd have to probably update your Kubernetes deployment if you're using a new tag to tie it to that new tag. And then you need to use the kube control tool or something similar to deploy it to the cluster. So Scaffold does all of these things with a single command, and it will also watch our code repository locally for any changes. And if it sees any, it will automatically deploy them. And hopefully you'll see throughout the demo that's actually really useful when you're iterating and making changes. You don't have to kind of keep running the same command again. Scaffold will just sit there in the background and run it and run for you. So this configuration file for Scaffold has also been set up something called Paketo build packs. Now this has recently been accepted into the CNCF. What build packs are, they're really one of the main benefits is that they eliminate the need for writing your own Docker files. They provide you like a really minimal sort of base image and provide you the up-to-date versions of the JVM, really like an opinionated kind of way of building a container. One of the sort of other benefits is that you can ensure, if you're working with multiple teams, that all the teams are playing on a level playing field with their images. So you don't have the kind of notion of like a snowflake container where one team's using OpenJDK, the other team's using Oracle or something. You can make sure that everything's at the same patch level, which is, especially in enterprise, this is a really good benefit. The other thing we need to configure here is we need to tell Scaffold where to look for the Kubernetes manifest. So we've got two here, one for our animal rescue backend and one for the external API. Okay, so let's actually run the build. So as I said, it's just going to be a single command, Scaffold dev. Okay, so this is actually going to take a little bit of time. So what I'm going to just do is go back to my IDE and just talk to you a little bit more about some of the other things that we've got in the project. So first of all, we're going to look in the backend folder. Get that. We've got this Kate's directory that contains all of our manifests, and we've got this thing called customization.yaml. So what Customize is, this is a tool that really helps you cut down on the amount of YAML that you need in a Kubernetes project. Customize is actually included in the kube control command line binary, so really there's very little friction in adopting it. And we've certainly found that it's definitely something can add a lot of value to the teams. So what this configuration is doing is automatically going to add a namespace tag to all of our deployment service files. Just add the namespace animal rescue. So this is probably quite a small change, but it's one of those things where every little helps. And again, it's going to add this set of common labels. And these labels are really quite powerful, especially if you're managing lots of services at the same time. So for example, we might want to kind of look at all of the different Kubernetes objects that relate to animal rescue. So we've got this name label. So we could use kube control and say, show me everything that has this label. And at even higher level, we could even say, okay, well, show me everything that's running Spring Boot 2.3, for example. So definitely recommended to use these labels when you're doing deployments. Excuse me. So we're also using this thing called a config map generator. Now, what this does is it's going to look at our file that we've got here called application YAML. And this is just a standard Spring Boot configuration. And what the customizer will do, it will just take that and it will package it directly into a config map. Okay, so now we'll take a look at our Kubernetes deployment. So what this describes in the deployment, it tells us what image to use. So this is going to map back to what we defined in our customization file. What you'll notice, there's no tag here. So Customize is actually going to automatically update this for us and pin the kind of latest tag to it. And this is actually really powerful because what that means is then you can, it's kind of like an immutable image, right? So you can have, you're not constantly overwriting the same tag. So it will give you a new tag every time you deploy it, which is really useful. We also have a number of replicas here, which is for high availability. We just got one at the moment, but it's really, you can just increase that number and have more replicas of your application. So we've also got these things called probes, and these just tell us, well, Kubernetes will check, is your app, has it started? And once it started, is it healthy? So we call these liveness and readiness probe. And Boot actually provides a set of standard actuator endpoints for these, which is really useful. We also say which container port to run, and this needs to be one of the same as what we have in application YAML, so 8080. And we also set some environment variables. So what we're going to do is we're going to tell Spring where to look for its config file. So this is because it's a config map. It's actually going to be mounted as a file in the container. So the Spring Boot app, we tell it where to look for it, and we're going to set up a volume. So yeah, we can find it all. And then we have a service, which we briefly covered. So our type of service is a load balancer, and what that means is that the service is actually going to get a real sort of publicly routable IP address that we'll be able to access from over the internet. Okay, so let's go back to Scaffold and check our build, and hopefully that's all run. Yes, that's looking good. So just quickly talk you through what's sort of happened here. So go to the top of the output. So what it's done, it's found something called a builder. The builder here, that's responsible for actually doing like the build process, so running like, in our case, like a Gradle build. So you can, if you go down a bit further, there's like a detection process here, and it's found, okay, this is a Gradle file. So it's automatically going to run a Gradle build. We can see the command here, it's executing Gradle test build. So that's gone and does the Gradle build for us. And it's also detected what kind of sort of app this is. So it's detected that it's a Spring Boot app as well. That just means that it can add some extra metadata, which could be useful for like things like you can contribute to the actuator and that kind of thing with that metadata. And if you go down, it's actually gone and tagged our image, and it's pushed it to Docker registry. It's used a SHA-256 tag just so it gives it a unique image tag. And then it's gone and actually created the Kubernetes deployment. And what it's doing is it's just printing us the log. So as I said earlier, this just really kind of simplifies the amount of commands that you need to run. Okay, so now we're just going to have a look at what is actually created. So we'll do the command kube control get all. And you can see we've got our pods that are running. We've got our services with IP addresses allocated. And now we can just quickly open up our service in a browser to have a quick look. I'll just copy and paste that. And there we go. So it's really, we got a very, very well designed website, which Bella did a lot of work with, and we can actually go in and see the animals that are available for adoption.
They're the cutest.
They are the cute, paprika especially. Yeah. Okay, so I'm just going to go back to my slides now. And okay, so on to our next how to add some authentication. So I really don't blame you if you're rolling your eyes looking at the title of the slide. So basic auth isn't the first thing that comes to mind when you think of secure systems. But the truth is that basic auth still is a useful tool, and really its simplicity is both a blessing and a curse. So, and I always sort of argue to people that basic auth is much better than no auth, right? So, and even with the sort of more complicated systems like OAuth 2, that they often actually use basic auth when you're doing things like retrieving a drop token from a URI. You still need to provide basic authentication to get that initial token. You can also actually use basic authentication to build much more sophisticated sort of API token-based mechanisms as well. So the way it works, really, it's very simple, and it just passes the username and a password as a base64 encoded header. One of the main benefits of basic auth is that you don't need any kind of extra infrastructure. You don't need anything like an authorization server or anything like that. Okay, let's go for another demo. We're actually going to add basic authentication to our application. So the first thing that we're going to need to do is we're going to create a secret. So the secret in Kubernetes is just a way of storing secure credentials. So I'm going to go back to our customization file, and I'm going to add this thing called a secret. No, I'm not going to add that. Sorry, excuse me. I'm going to add customization. Yeah, so what this is doing, this is a secret generator, very, very similar to how the config map generator is going to create a secret called animal rescue basic. Type is opaque. Don't worry about that terminology too much. It just the other type you normally come across is like TLS. It just means it's a regular set of credentials. What it's going to do is look at this file called secret.m to get the actual credentials. So this is actually git ignored. So I haven't committed this into source control. So it's just a way of making it more secure. So it's just going to create a secret with the username Alice and password test. So the next thing we need to do is tell our Kubernetes deployment to actually use these credentials. So we'll go back to our backend deployment. And we need to, in our end section here, just need to add in some more environment variable mappings. We've got animal rescue basic password and animal rescue basic username. So these are configured so Kubernetes knows how to map an environment variable from a secret and take that and put that directly as an environment variable. And this is the other thing you can do is mount it as a file, but for simplicity, we're just using environment variables. But the good thing about that is that Spring Boot understands how to convert this environment variable into an actual like a Spring bean. So we'll have a quick look at that file. So what we've got here, you can see we've got this configuration properties annotation, and this is just like a marker, and this is going to convert our. This tells it to if it sees that environment variable that we defined, it's going to map that onto this string username and string password. So you can go back to scaffold, and hopefully it's automatically detected that I made a change. It did. So just running through that now. Shouldn't take too long, hopefully. What we can do in the meantime is do this. Have a look at. You see that one's. So what Kubernetes does when it does redeploy it does zero downtime. So we've got the old one still running. You can see there. So, and see now it's terminating. So hopefully, if we go back to here, yeah. So now waiting for changes. So we should be able to now access our app and see that it's now protected with basic authentication. Let's give that a go. So what I'm going to just do is I'm going to make this a little bit easier. I'm going to extract the IP address so I can into a shell variable here, and I should be able to say echo $IP. Yes, that worked. Good. So let's curl it and see what happens. And as we hoped, we've got now 401 unauthorized. So let's just add in the username and password, Alice and test. Just using this JQ tool to make the output a bit nicer. Yeah, there we go. So that worked. So now we mentioned earlier that we've got this partner API that needs to access our animal rescue service. So that's now going to probably be broken. We can just open it up and have a look, because we haven't configured it with any of it. Was working, but it doesn't been configured to know what our username and password is. So let's just have a quick look. So you can see here we've got Partner Adoption Center. Should be able to open that up in my browser.
That was the cluster IP. You need the external IP.
Good spot, thank you.
That's why we pair.
Exactly. Oh, and we've got this really helpful error message that says, oh, it's status 401. So let's fix it. So what do we need to do? So what we're going to do, and this is another reason why Kubernetes secrets are quite useful. So what we can do is we can tell the partner service just to use the same secret as the animal rescue service is doing it, and use that secret to get the credentials it needs to make a basic authentication connection. So what we'll do is open up the deployment file for the partner service, and I'll add that in. Okay, so yeah, it's just referencing exactly the same secret. And I'm also just going to quickly edit some JavaScript, and bear with me, I'm not a JavaScript programmer, so hopefully I get it right. Thankfully I've got Bella here too, who does know a bit more than me. So just going to, I think, just change this line here. So at the moment it's just doing a plain old get, so we just need to change that. So it has the username.
We still need a return statement.
Thank you, this is why we pair.
Also, Ollie, I think we're running a little behind time.
Okay,
maybe a lot behind time.
Okay, let's skip forward. Thank you for pointing that out. Okay, so basically what I was going to show you is that we just need to make some configuration, so you just have to trust me that it works. Let's go. Let's move on to the next section. So back to this diagram, we can see that we can protect, just using Spring, we can protect our HTTP endpoints using authentication. But the problem is that in our example, we also had this Node.js application. So we could also configure Node to use basic auth, but there's there's a number of security libraries to do this. But the problem is that that means we need to maintain and understand kind of two sets of libraries. The more apps we have, that's the more security configuration that needs to be maintained, and more things that need to be updated. And I think generally, when dealing with security, it's better to reduce the number of dependencies, as it that means there's less potential vulnerabilities. So what Kubernetes does let us do, it lets us put a layer in front of our application that acts as a front end to our HTTP requests, and route them to the right place based on the URL. So this is known as ingress. However, sometimes vendors might call this a different name, like gateway. But for our demo, we're going to use Nginx ingress, as this is quite often the default ingress controller that's used in many Kubernetes clusters. And ingress lets us do quite a few things, like rewrite HTTP headers. But what we're going to use it for is actually setting up basic authentication again. So demo time again. So what we're going to do first. I've already installed an ingress controller before the demo to save time. What we can do is just quickly have a look at it. Oh, no, not that. Excuse me. Bear with me. So yeah, we can see that's already installed, and this is the output you would get if you would install it yourself. And we can just have a look quickly at the sort of services that the ingress uses. So we can just do. So I'm using these kind of abbreviated aliases. They're actually really useful, but it does print out the full command underneath. So you can see here that you've got it's got the ingress controller itself has got an external IP here, and this is going to be the same IP that all of our ingress resources will actually use. So now we've seen the actual ingress controller, let's actually go and set up some ingress resources for our app. So move to a different folder. What we've done is we've created a top-level K8s folder, and this sort of contains all the stuff that's kind of global to both of our apps. So we've got a animal rescue ingress, and what we've done here is got these annotations, and the annotation is just the way of kind of configuring the ingress. And we just told it there's an auth type of basic, and that there's an auth secret called ingress basic auth. What we'll need to do again is to create a secret generator and customize to actually generate that secret for us. Let's keep doing that. Excuse my copy and pasting. Okay, what I've done actually is this option to disable the name suffix, just because we want to, what customize will do otherwise is append a hash to it, but we want to disable that behavior just by default. So we've got our, that will generate a secret for us. And now we're just going to edit our scaffold file to make sure that we're including all of the files that we need for the ingress. So that top level Kate's folder, and should be able to go back to our scaffold build. Yeah, it's detected it. While that's running, I'll just quickly show you a bit more about the ingress resource does. So we've got these rules, and what we're using is just like subdomain host base mapping. So we're saying, although they're the same IP, if it's the spring.animalrescue.online subdomain, it's going to map the request to this service. If it's the partner subdomain, it's going to map it to that service. What I've actually done here is actually edited my host file with these. You can see it here, just to save time again. But in reality, you'd want to create a real DNS record, which we're going to do a bit later. So there we go. So now what I should be able to do is, with a bit of luck, I should be able to curl this address. And as we'd hoped, we've got a 401 authentication error. So what I'll do is add in the user password again. Oh, got a problem. Oh, that's not so good. It's not what I expected. Might just be that things aren't ready yet. Okay, I'm not, because haven't got much time. I'm not going to try and fix this. I would have tried and fix it otherwise.
That's okay. It's live demo.
Yeah. So you have to take my word for it. That basically what that was going to do is actually just it did authenticate our app. It just didn't. For some reason, the routing from the ingress to the app isn't quite working. So let's go back to our slides again. So we've seen how you can use ingress, but one of the things that we didn't actually do is protect our app with TLS. So I'm going to pass on to Bella to cover that part of it. Stop my screen share. Excuse me. Sorry, I'm just having some Zoom issues.
Okay, thanks, Ollie. So when we're using unencrypted HTTP protocol, someone can be spying on us in the dark and steal our credentials and all the data we're sending or receiving from the transport layer. We really need to enable TLS to encrypt everything. But how do we do that on K8s? First, we need to decide on a publicly trusted CA to issue certs for our services. For this demo, we'll be using Let's Encrypt. Then we'll need something in our cluster to communicate with the CA to issue new certificates and renew a certificate when it's expiring. We will use Cert Manager for that. Last, we need to enable TLS on our servers by consuming the created certs and terminate insecure connections. We can do that with Spring Boot SSL configurations. However, in this demo, since we already have an ingress layer handling basic auth for our apps, we can delegate TLS to ingress too. So let's start demo. While I was waiting for the previous demos, I have pre-installed our Helm, the Cert Manager with Helm. So Cert Manager output is kind of helpful. It's saying in order to begin issuing certificates, you will need to set up a cluster issuer or issuer resource. I'm just going to copy this file name. And they have more information on their website in their doc. So a list of issuer types, and ACME issuer is the one we're looking for because that's the one that Let's Encrypt uses. So down below here, I'm just going to grab this sample one and use that as our starting point. I'm going to create an issuer called, let's encrypt. And I need to tell it it's a YAML. Put the content inside. So since we're running out of time, I'm just going to quickly go over the demo and not really explaining every field. But if you have any questions, totally come to our Zoom later on. And normally, we recommend to use the staging server first to verify your creation of the wiring of Let's Encrypt, because the prod server has rate limit. But in this case, we're running out of time, so I'm just going to do prod and be bold and just see what happens. In the solver section, we specified HTTP 01 challenge. This is defining the flow of cert issuing. Let's talk about what that means. Back to the slides. So we start with asking Let's Encrypt for a certificate. And look, Let's Encrypt replies with a haiku. Here is a token. Serve it up with your server. I will check later. We have no choice but to put the file derived from the token and our private key on the web servers that our domain is pointing to, and notify Let's Encrypt. Let's Encrypt then retrieves the file from ACME challenge path on our domain. Because of this step, our domain needs to be publicly accessible and can't require any authentication. Otherwise, Let's Encrypt won't be able to verify our file. So to save time in this demo, I have created the DNS record ahead of time for my domains. Once the file is validated, Let's Encrypt will note it to themselves with another haiku. I trust this account. I will grant a valid cert on the next request. Then we can claim our victory and retrieve our cert. By setting the HTTP 01 solver on our issuer, Cert Manager will help us to get through the challenge. And let's see, how do we actually encrypt? So this is our issuer. Let's encrypt issuer definition. Let's just add that to our customization. I have scaffold running in IntelliJ here. And we also need to annotate it on our ingress. What's going on? Live demo is never going to go right.
It's like maybe some YAML in typoed.
Oh, wait, they updated their doc overnight.
That is a real live demo problem.
This is a real live demo problem. I think they were using beta 2 or
So they
something.
changed the API version. Wow.
Yeah. Still, no, doesn't like it. Okay, I'm going to cheat. Not that one. Don't panic. Don't panic.
Beep, beep.
Think. Oh, it's alpha 2. I'll just copy the whole file and put it here. Okay, now it seems a little better. And in the ingress section, we need to annotate our ingress so our ingress knows how to do TLS termination. So let's add some annotation first for using the cluster issuer. And this annotation will tell ingress to not use basic auth to protect the ACME challenge path so that Let's Encrypt can verify our token. And we also need to enable TLS for our hosts. Let me just add that here. So this is the same host name we're using here. And so Cert Manager will check if the secret already exists. If it exists, it will use it directly. And if it doesn't, it will create a new certificate using the HTTP challenge for the host we specified here. Let's see if our certificates are ready. Yep, they seem to be ready. Let's see. What's my URL here? We have our domain name set. And it is from Let's Encrypt. Oh, and because I copied it from the staging file, so my Let's Encrypt is still using the staging server. Let's just quickly, hope we still have time to go through to the prod server. And it's the same file. And here we'll switch over to use prod server. Successfully updated. Get certificate true. Let's go back to this page again. I'm looking for a lock. Oh no, live demo, isn't it? So the Let's Encrypt file here, we have specified prod, added that, and then we're using prod. Oh well, live demo. That's fine. At least we verified that Let's Encrypt works. So if you have time later on, maybe you can chat in the Q&A Zoom and we'll figure out why this didn't happen.
Is staging still better than self-signed? That's one
That's true. And we only have one last thing to verify. It's probably because I switched back and forth between prod and staging and something went wrong in the middle. One last thing is that I really want to make sure the HTTP URL is no longer valid. So if we just curl at the HTTP, using the HTTP protocol, we can no longer get a response back. It is 308 permanent redirect, and we have to use HTTPS. And because it's staging, it's not a valid cert, we need to skip that validation. And we got 401 again. So that's using Cert Manager to add TLS. And in this demo, I manually created the DNS record ahead of time. If you have a DNS admin account, then you can automate adding DNS record as part of the deployments. An important thing to note here is that DNS record takes time to propagate. So creating DNS record on the fly will slow down the HTTP challenge process. Depending on your business need, the benefit of automation may outweigh the delay. So let's quickly see how to do this. We'll install a tool called external DNS with Helm chart. This time we need to provide some additional values so that external DNS knows which cloud DNS we're talking to. So I have this values file here, version controlled, so we don't need to always tune it. This is the accounts, the service secret account is what external DNS uses to manage our DNS zone. So we need to create a secret to actually include that. And I'll just add one secret generation section in our customization. So I'm creating a secret using this GCP DNS account credentials I just put down with gcloud CLI earlier. This is not checked into Git, so don't expect to see that if you're checking out our code base afterwards. And we're ready to install the chart. So I'll just using the new way of installing a Helm chart, which is putting that as part of scaffold. And this way, if we change any values in our values file or change anything related to our DNS, scaffold may actually upgrade our Helm chart for us. And also, while we're waiting for scaffold to install everything, let me just see if it's actually installing. Yeah, it's still finding stuff and tagging and trying to install the Helm chart. Let's just start watching on the cloud DNS we have. So right now I have two DNS records, Animal Rescue Bella and partner.bella. Let me just start another window to start tailing the log from external DNS. Ooh. We got some logs from Ollie's operations. That's fun. Let's see.
Sorry.
No worries. This is totally perfect. Fine. Let's try ingress. So let's try just adding another ingress rule. So we have another URL for external DNS to execute on. I'll just call this Spring1. And we can see that scaffold is doing something again. Seems to finished. External DNS watches Kate's API server every minute. So it's like watching on a 1 minute interval. And during this whole time, it will consolidate a list of domain names to add or remove. Oh, look, we have hit our 1 minute wait already, and a new DNS record is created. And back to slides. So with external DNS, we no longer need to manually add DNS entries for adding TLS cert. And with TLS enabled for our application, basic auth is now safe. The hacker monkey cannot see our secrets anymore. But what if we want something more flexible, like accessing our Kate's app with GitHub account? I don't think GitHub would agree to share their user database with us, so basic auth won't work anymore. We need OAuth 2 for this. I'll stop share right now, and Ollie will show you how to use OAuth 2 in Kate's. Ollie?
Yeah, I'm with you. Sorry, I'm just sharing. There we go. Desktop 2. There we go. Oh, wrong one. That's my Slack. Right. Okay. So yeah, let's look at how we can use OAuth 2 as really a much better improvement of what we had over basic authentication. So what we're going to do is use a small project called OAuth 2 Proxy, which is just written in Go, and it interfaces with our multiple authorization backends. The reason we choose OAuth 2 Proxy is just because it's very lightweight and easy to configure. And then what we're going to do is we're going to build on what we did previously and configure Nginx ingress to use the proxy. So it will authorize all of the requests that come to it and use an external authorization service. So again, it's deployed with Helm. So I've just got the Helm values configuration up here. Again, I've already deployed it just to save a little bit of time. So we're going to use GitHub as the backend, as it's quite a flexible service. And you can see on line 7 there, that's where I configured that. And we've also configured a secret. So it needs to know a client ID and a client secret. And the way we actually get that is via the GitHub website. So you've got here, so what I did is I created this animal rescue OAuth 2 application in GitHub, and that's given me a client ID and client secret is generated. And that's the thing that we'll put inside of that Kubernetes secret. And the other things I had to actually configure is the homepage of the application and also the callback URL. Now, hopefully this is going to work because I was just noticed in Bella's demo that some DNS records were deleted, so fingers crossed. Let's go back to our deployment. So we've registered our application, and what we also need to do is edit our ingress file. So we've got external OAuth 2 proxy. Sorry, bear with me. We've got animal rescue external ingress, and what I've done is added these annotations here. So this is just telling the Nginx ingress that it needs to go to this external OAuth 2 proxy URL for authentication, and also tells it how to sign in. Okay, so the other thing you might notice is that I changed the subdomain to kubedemo just to avoid the risk of us potentially hitting the Let's Encrypt rate limit. So let's cross our fingers and hope this is going to actually work, and we'll try and... I think
I actually messed everything up because I skipped a step of changing the sync policy of external DNS to Autocert only. So I think I deleted all your stuff.
Let's have a quick look, see what's happening on my machine. We might be in luck. We don't have a great deal of time left, but let's just have a quick see what the logs are saying. It might have maybe we're fighting with each other. With our having.
I think we're fighting with time because we didn't go through all the steps.
So it claims that I might have did your deletion. So let's our fingers crossed.
Oh, your external DNS did the addition too. Great.
Yeah. We're in some serious conflict here with our two demos. Okay. So next thing, what I'm going to do is open a new private window just to make sure any authentication is not been cached or anything like that. So let's do that. Private window, and it's going to be Ollie.cube demo, and it's not. Yeah, okay. I'm not going to try and do this because obviously there's been some DNS. It's always DNS. That's what they say, right? So. But what was going to happen is that was going to redirect to GitHub for authorization and take us back to the animal rescue site that by now we all know and love. So I'm going to hand back over to Bella to talk about service-to-service communication.
Whoops, share screen. There we go. Whew, DNS, it's terrible, right? So it's like knowing that OAuth 2 works for users. We also need a way for machine clients to prove their identities without using a million passwords. By default, the TLS protocols only proves the identity of the server to client, and the authentication of the client is left to the application layer. What if we enforce this TLS validation both ways? Can we delegate client authentication to TLS too and further secure these services from attackers? Yes, and that's mutual TLS, also known as two-way TLS, or just mTLS for short, if you just hear that acronym. As part of the handshake, just like how client verifies server's cert, the server would also ask the client for a cert and make sure it's issued by the same CA. In this case, we're going to use a private CA because we need full control over who can access our services. If we were still using Let's Encrypt for mTLS, then anyone who has cert from Let's Encrypt would have access to our services. And that's not what we want. Before we dive into the tools that can help us with mTLS, let's take a quick look at what needs to be done if we were going to do it manually. We need to create a private CA cert, then use it in your cert manager's CA issuer. Then we can issue certs for our applications and make them available on your application containers. Last, we need to make sure the applications know how to do mTLS with the certs. This process is not trivial, but don't worry, Autocert can make it easier. Autocert is a Kubernetes add-on that comes with deployed CA and automatically inject the generated certs into your container. It takes care of the steps in the green area for us. Applications still need to do the last mile wiring to use the cert, but it's a lot less YAML to worry about. Let's do a quick demo of it. Screen here. So first thing first, we need to install Autocert, and I forgot to do that early on, but it should be relatively quick. Here we go. And the output here is actually telling us exactly what to do. So let's just annotate our animal rescue namespace here. Can't really type. And the next step tells us how to check which namespaces have Autocert enabled and our animal rescue is enabled. So we just need to go to our Node app. Oops. Go to our Node apps deployment and add an annotation to our pod. To the metadata. This is telling Autocert to create a sidecar that generate a cert with this common name for us. And that should actually just take care of all the cert generation for us. What happens right now is Autocert will deploy a sidecar next to our Node app and share a temporary directory for cert files. Oh no, am I seeing any changes here?
Maybe just yeah, there you go.
Yeah, we can see that scaffold is really helpful, but sometimes it's a little slow in React. So actually, I should have just used kubectl to annotate this pod. Okay, so the sidecar uses a one-time token to generate an initial cert. Then for renewal, it will simply use mTLS. Let me just get all the pod right now. And yeah, we have the pod ready. Let me copy that. Okay, describe pod. we can see that there are two containers. There's Autocert renewer containers, and there is now a cert volume that is a temporary directory. That means if the pod is destroyed, the certs will be gone and it's not going to be stored anywhere. And both these containers are have this certs volume mounted under this path. So let's get into the container and see what's under that path. Where's the pod name? Here. I'll just list out all the files under this path. And we got our cert files. We got a root CA and the cert and private key for this site. Let's describe on the cert created for this service. We have the correct subject set, and the cert is valid for only a day. And at that point, the Autocert renewer sidecar will take care of the renewal. The certs are created now, but mTLS still is not fully wired up because Node app also needs to know how to do mTLS to use the cert. I'm just cheat here. We're in this file, compare with branch mTLS. So that's the import. I'll just take that. This section, we tells Node where to find the CA search files. And this uses the search file to create secure context. This will create the initial context, and this file watch will watch on any cert file changes and recreate the secure context. And in the server options, we tell the server to always request the client certs and reject any unauthorized requests, passing in the secure context we just created up above and serving it up with HTTPS. Let's take that code in. And that should be the code changes we need to enable the Node app do mTLS. Oh, also, because we're serving it up with HTTPS instead of HTTP, we need to put it on port 443 in our service definition. That should take care of the server. And for client, I actually have this curl mTLS client, so let's just deploy that as well. What this does is it knows how to use the cert injected by Autocert and periodically make requests to this URL we specified here. I have no idea how long would that take. Should have done kapply. It's running with two containers as well. So I'll just skip looking at what that container does and just log into the container and do the curl command by hand. I will copy paste this. Okay, so this curl command will just use the cert files that Autocert generates us and make a request to our partner's Node app. And we got our response back. It seems pretty happy. And just to make sure that we actually have mTLS enabled, it's just not like you provide a cert, but that's fine if the server doesn't validate it. So let's make sure server also validates on that. Let's just make a curl request without any certs. We now get fail to verify the server's cert. That's because mTLS relies on the private CA. So without any CA, without specifying the root cert, curl wouldn't really know whether to trust it or not. So curl cowardly terminated the connection. Let's tell curl to be bold and trust the server cert. And we got a different error. We got a handshake failure. This is because even though the client trusts the server still doesn't trust the client. So we got rejected. That's all the demo I have for Autocert. So knowing how it works, let's discuss our feelings. There are a few good things. Certificates are generated locally on the pod and are not stored in Kubernetes secrets or transmitted across the network. This makes it really secure. And like we just saw with the demo, it's pretty easy to set up and run. And if you're migrating applications that already knows how to use cert files, Autocert is just perfect for you. A few things that are not as good. Applications are responsible for ensuring mTLS. They need to know how to use the certs. This is especially complicated for Java apps because Java consumes trust store and key store instead of the cert files. So we will need to manually import the files into those stores. Applications also need to be watching for file changes and reload the cert. Again, Java apps need some extra work to rebuild the trust store. In terms of access, any pod can get certificate with any identities in the enabled namespaces, and they can all talk to each other freely. There's no way to restrict the direction of the communication at this point. If you want the whole mTLS process automated without code changes and have more fine-grained control on who can talk to your services and who your services can talk to, you can take a look at Service Mesh. Service Mesh deploys the sidecar next to all your services. Unlike the sidecars deployed by Autocert, which only handles the creating and injecting certs part of the job, the sidecars from a Service Mesh also handles inter-service communications and handshakes. Your applications no longer need to know about TLS. Requests without a valid cert gets terminated.
Well, thanks so much, Bella and Ollie. I do have to cut you off there because we are at time. But this has been fantastic.
No.
We had over 7,000 people watching you live.
Wow. Watching us fail.
I didn't want to tell you that.
Our demos.
I didn't want to tell you that beforehand, so I didn't want the pressure. Yeah. And special shout out for using external DNS and Cert Manager because they are excellent projects. So thank you so much, and we will move on to the next session in a few moments.